Let's take a look at problem number 41. 41 has three parts. There's a part A, a part B, and a part C. And in part A, we want to use the definition of the derivative to determine the derivative of ax squared plus bx plus c, where a, b, and c are constants. Part B, I want to let f of x equal 4x squared minus 3x plus 10, and then use part A up here to find the derivative. And then in part C, let's use part B to find f prime at 1. Okay, so let's start with part A, and we want to use the definition of the derivative to determine the derivative of ax squared plus bx plus c. Okay, so to find the derivative of ax squared plus bx plus c, then I want to take the limit as h goes to 0 of this function f of x plus h minus f of x over h. And let's plug it in real quick. If I do this, I'm going to have to write kind of small, but I get the limit as h goes to 0 of, I need to plug in x plus h everywhere where I have an x in here. So if I do, I get a times x plus h squared plus b times x plus h plus c, and then I need to subtract f of x. So I subtract all of this. So if I subtract all of that, I get a minus ax squared minus bx minus c all over h. Okay, so all that I did here is I took the formula for the derivative of a function, and I plugged in the actual f of x plus h value and the f of x value. So far so good. Let's expand this thing. So if I do, I get the limit as h goes to 0 of, if I square this piece out and multiply it by a, I'll get an ax squared plus 2a xh plus a h squared. Then I multiply both of these by a b, and I get plus bx plus bh. Then notice that I have a plus c and a minus c on top. I'll just cancel those. And then I'm left with a minus ax squared minus bx all over h. Okay, does anything cancel here? Yeah, a few things do. I've got an ax squared and I've got a negative ax squared. So the ax squareds cancel. Then I've got a bx and a negative bx. So the bx's cancel. And what I'm left with is a bunch of stuff on top that all involves an h. So let's go ahead and factor an h out, and I get the limit as h goes to 0 of h times 2ax plus ah plus b all over h. Notice now that the h's cancel, and I'm left with the limit as h goes to 0 of 2ax plus ah plus b. And as h goes to 0, this ah becomes 0, and I'm just left with 2ax plus b. And so what I calculated is that the derivative of this function, ax squared plus bx plus c, is 2ax plus b. All right, now let's look at what part B asked us for. Part B asks us, okay, so now let's take a different function, 4x squared minus 3x plus 10. But this is exactly the same as this function, ax squared plus bx plus c, except that 4 is a, negative 3 is b, and 10 is c. So if I want to find the derivative, part B, f prime of x, well, I know that it's just 2ax plus b, no matter what a, b, and c are. In this case, a is 4 and b is minus 3. So I get 2 times 4x, which is 8x, and I get b, which is minus 3. So minus 3. So the derivative of 4x squared minus 3x plus 10 should be 8x minus 3. So that's part B. And then in part C, we're asked to use part B to find f prime of 1. Well, f prime of x is 8x minus 3. So f prime of 1, I just plug in 1 for x and I get my answer. If I plug in 1, I get 8 times 1 minus 3, which is 5. And so f prime of 1 is 5.